All right, so more practice here. This is the key, right, to the course, as you guys know. It's just doing a lot of practice. So uh, we're gonna do next, draw the Lewis structure of lithium fluoride. Okay, well, first thing to realize here is that we have a metal and a non-metal, right? Lithium is on the left of the periodic table, fluorine's on the right. So this is an ionic compound. So if we drew the octet, the Lewis structure for lithium, it has one valence electron. It's going to look like that. And if we drew it for fluorine, it's going to look like that with 7 valence electrons. And so we're going to transfer an electron to the fluorine. That's going to give us a positive charge for the lithium, right, because it lost electron, and a negative charge and an octet for the fluorine. And so that's basically it for this one. All right, next one, let's do NH4 plus. Okay, so this is a covalent compound. We're back to covalence, both nonmetals. Most of the questions on these are going to be covalence, but you got to check. Okay, both nonmetals. Number of valence electrons, 5 for nitrogen. There's 4 hydrogens, good for 1 each, but we have to subtract 1 because we have a positive charge. So that's going to get us 8 valence electrons. Hydrogen can't be in the center, so the nitrogen is going to be in the center. So that's going to get us something looking like that with a positive charge. Hydrogen duet rules are all satisfied. 2, 4, 6, 8. Nitrogen duet rules satisfied. How many valence electrons total do we have? We had 8 total valence electrons. We have 2, 4, 6, 8 valence electrons. That's our final answer. Next one, C2H2. Okay, and so, I've been working through all the examples that are in the slides. If you're not looking at these videos and just looking at the slides, we're going through all of them. Valence electrons. Carbon's good for 4. There's 2 of them. Hydrogen's 1. There's 2 of them. That's going to give us 10 valence electrons. Hydrogen has to be at the end. That means carbon's going to be in the center. Get our skeleton set up. And at this point, we don't have the octet rule satisfied for carbon. So let's try to do that. Hydrogens are fine. We have 2, 4, 6 accounted for. So 8, 10. That's what we would be stuck with at this point. Carbon's still not looking good. We have 2, 4, 6 for carbon. Okay. We can't make a double bond with hydrogen. That would make an expanded octet for hydrogen, and we can't do that, right? Because hydrogen can only have 2 valence electrons. So at this point, we're going to have to erase a lone pair and make that into a double bond between the carbon. Let's see if that helped anything. Well, it helped this carbon here, 2, 4, 6, 8. But this carbon here is still 2, 4, 6. So we need to get 8 for this carbon. So the only way to do that is to make the other lone pair into a valence, into a triple bond, right? Into another bond there. And so that is going to be our final answer. Let's check it. Hydrogen has 2, hydrogen has 2, carbon, 2, 4, 6, 8. Good. Carbon, 2, 4, 6, 8. Octet rule satisfied. Total number of electrons satisfied. 10 electrons here. 2, 4, 6, 8, 10. So we're good. A few more, guys. Xenon Difluoride. Now, this is kind of a weird one. Xenon is a noble gas. It's an exception. You can have some noble gases will make compounds, okay? This is actually a whole brand new field of chemistry that was only discovered till the 1960s. Before then, people thought it was impossible. But xenon can, in some rare cases, with really electronegative atoms, i.e. fluorine, basically, it can make a compound. And so this is going to be, as you'll see, a violation of the octet rule. Why? Well, let's go through it. Xenon has a noble gas, 8 valence electrons. Fluorine is a halogen, 7 times 2. That's going to get us 22 valence electrons. Xenon, we're going to put in the center. I don't know about the electronegativity of it. It's usually not reported, but Fluorine is the most electronegative, so xenon better be in the center. It's going to be more electropositive. Okay, and let's give an octet to xenon, to fluorines. And at this point, would be 2, 4, 6, 8, and then 8 for here. So it's a total of 16. We need 6 more electrons, and we're forced to basically put them all in the center. But you'll see 2, 4, 6, 8, 10. That's a violation of the octet rule. It's expanded octet, but xenon is, well beyond the third row. It's what is it in the? It's in the 5th row. So that's totally fine. And so this would be our structure here. Okay, even more problems coming up in the next video. Just trying to parse out the videos here.